Atomic radii, the first topic that we are going to study is atomic radii. When I say radii or radius, fine, don't get worried, it is one and the same thing. So it is basically the distance between the nucleus and the outermost electron. Okay. Now okay. Now see, in this diagram I am making complete circles, but it is not necessary, because they are clouds. Clouds generally do not have a fixed shape. So suppose this is the shape of atom. So what we are saying is, from here I am measuring this distance, from here I am measuring this distance, here I am measuring this distance, here I am measuring this distance. And moreover, the electrons are not stationary ना बेटा, ऐसा तो नहीं इलेक्ट्रॉन एक जगह खड़ा हुआ है, आपने ऐसे डिस्टेंस मेजर कर लिया. See, मेरी हाइट कैसे मेजर होती है? How do I measure my height? You take a measuring strip from the foot to the head, okay? Because my head is stationary, my body is all stationary, so you can measure my height. But suppose if all the parts of my body are moving here and there, would it be possible for you to do the measurement? You will say, no sir, it is not possible. Exactly. All the electrons over here are moving, they are not fixed, so it is not possible for you to measure the exact radius. And that is why many of the centers over here have used the word average distance, okay? They have used the word average distance, and that is the correct word. So average distance between the nucleus and the outermost electron. What I have said, the distance between the nucleus and the outermost electron, it is the average distance between the nucleus and outermost electron. See, in a periodic table there are periods, so it is like left to right in a period. क्या होते हैं बेटा period? What are periods? Periods are horizontal rows and down the group. What are groups? Vertical columns. So you have merged the T and H over here, so it is down the group, okay. Now we are talking about atomic radii, so I am writing it over here, atomic radius, okay. Now moving from left to right in a period, I am saying that the atomic radius decreases, whereas when it is going down the group, the atomic radii increases, okay. Fine. See what is happening to an electron. Let's look at this particular diagram. Okay. Now what does this diagram say is that there are repulsions. Use as many markers as possible. There are repulsions between the electrons in a particular shell. Right. That is one thing. Dekho, the blue color is showing the repulsion. Okay. And also there will be some electrons in the internal shells, okay. So there are some repulsions over here also, है ना? ऐसे repulsion होगा कि नहीं होगा? Will be having repulsion like this or not, right? So first thing that you are seeing over here is repulsions. Which repulsions are there? You will say, sir, electron repulsions, right? That is one thing. And secondly, all these electrons are attracted by the nucleus. So that is nucleus electron attraction. nucleus electron attraction. So these are the two opposing forces. The attraction is pulling the electron inward and the repulsion is pushing the electron outward. Attraction pulling, repulsion pushing. So there are two opposite forces, right? There are two opposite forces. Tell me, is this part understood? That atomic radius, I'm just pushing it over here. Okay. Atomic radius is directly proportional to Z, or rather inversely proportional to Z effective. Now you will ask me, sir, what is this Z effective? What is this Z effective? Now Z effective is equal to net attractive forces minus net repulsive force. Okay. Attractive force is because of the nucleus electron attraction, but repulsive force is because of the electron-electron repulsion. You can calculate this Z effective also by using Slater's rule, but I'll teach you later on. Okay. So this is Z effective. Now when I move from left to right in the period, the attractive force increases, the repulsive force also increases, but the increase in attractive force is more than that of the repulsive force. That is why the Z effective increases and the radii decreases. Okay, let me write it down. So what am I saying over here? I am saying on moving from left to right in a period, the attraction due to nucleus and repulsion due to electrons increases, but the magnitude of attraction is greater than repulsion. That's why Z effective increases and atomic radius decreases. Is this clear to everybody? That on moving down the group, the atomic radii increases due to the addition of shells.